Hello engineers, welcome back. In the previous video, we solved a leet code question based on the prefix sum technique. In this video, we're going to practice another leet code question based on the same technique. Okay, let's get started. So this is a question we're going to solve today. It is called find the score of all prefixes of an array. So let's try to understand the question. Let's see how we can approach it, and we'll see how if we can optimize it, and then we'll code it. Okay. So let's try to understand the problem first. We define the conversion array convert of an array ARR as follows. Convert of I equal to ARR of I plus max of ARR of 0 to I, where max of ARR 0 to I is the maximum value of ARR j over j is in between 0 and I, 0 and I included. We also define the score of an array ARR as the sum of the values of the conversion array of ARR. Given a 0 indexed array nums of length n, return an array ans of length n, where ans of I is the score of the prefix of nums of 0 to I. Okay, so I know that this doesn't make much sense. Let's look at an example and see how the solution is given. Okay, so if this is an array that is given to us 2, 3, 7, 5, 10, and this is the output that we need to return. So how do we get to this output? So here they're saying for each prefix, so this is a prefix, 2, 3 is a prefix, and then 2, 3, 7 is a prefix, and then 2, 3, 7, 5 is a prefix, and 2, 3, 7, 5, 10 is a prefix. So for each prefix, the conversion array is built as we move along. So as you can see here, for every prefix, the conversion array is getting built. And how is that array getting built? So how is this value calculated? The value is calculated like this: array of I plus max of array of 0 to I. So for example, for this prefix 2, the conversion array is 4. So how did we get 4? So for this prefix 2, we need to get array of I, which is 2, and we need to get max of array of 0 to I. Now 0 to I, here I is also 0. So max of array of 0 to 0 is still 2. So 2 plus 2 will become 4. So the conversion array has one element here for 4. Okay, and then we have 4, 6 here. So how did we get 4, 6? So for this prefix 2, 3, now we have two elements in play. So we get the conversion array new value. So what is the new value? Array of I plus max of array of 0, 0 to I. So array of I is 3 now. 3 plus max of array of 0 to I. So whatever is the maximum up to this point. So among these two numbers, the maximum value is 3. So we get 3 here. And when we add 3 plus 3, we get 6. So we have 6 here. Okay, and so on. We fill out the rest of the array. And at each point, we also have something called a score. Score is quite simple. So it is just the sum of the conversion array elements up to that point. So here we have 4, here we have 4 plus 6, 10, here we have 4 plus 6 plus 14, 24, and then we have the sum of these 4 numbers, which is 36, and then we have sum of these 5 numbers, which is 56. Now they're saying you save these scores in a different array and then return it. So that is what we have written here. Okay, so the problem is a little bit lengthy, but not very complex in terms of implementation if we can break it down. Okay, so let's take this to our whiteboard and we'll build our solution. Okay, so let's say this is our array. Two, 3, 7, 5, 10. Okay, and we are dealing with a couple of other arrays here. One is the conversion array that we need to build, and then one is the answer array that we need to return. Okay, so we're going to need two other arrays. Both of them will be of the same length as our main array, and we need answer array here. So we need to build these two. Once we have these two, we simply need to return the answer array. Okay, so how do we build this? So looking at the question, we know that we need to build every element of conversion array based on this logic. And while we are building the conversion array, we also need to keep track of the score, and we need to return the answer array. Okay, so let's see. So let's iterate through our main array. For int I equal to 0, I less than nums dot size and I plus plus. We're iterating over the main array. Now we need to somehow fill this conversion array. So what is the logic? The logic is array of I, which is simple. We already have array of I. Now I is here, so array of I is 2. And we need maximum of array of 0 to I. So when we are here, the maximum of 0 to 0 is 2. So we get the value of 2 plus 2, 4 here. That's what we need. Okay, but as you can see here, this max is a repetitive loop. So when we are here, the max is 2, but when we are here, the max is going to be the max of all these values. So we need to check at every I what is the max of the previous elements up to I, right? So this is kind of running into a nested loop. So in order to avoid that, we can make use of a little bit of space, and we can probably use a new array and call it maximum or something. And this array will store the maximum values at each point. Okay, so at the first point, the maximum value is 2, and at the second point, the maximum value of these two will be 3, and at the third point, the maximum value of these 3 will be 7, and at the fourth point, the maximum of these 4 will be 7, and at the fifth point, the maximum of all these 5 values will be 10. So this is my maximum array. So if I have this array ready and handy, I don't need to calculate the maximum value for every iteration of I, right? I can just make use of this to build my conversion array. Okay, so let's do that. So how do we build this maximum array? So to build this maximum array, we know for the first element it is straightforward. The first element will be this because there is nothing else to compare. So let's do that. If I equal to 0, then maximum of 0, but this is a vector, so we need to use pushback nums of I. Okay, so we got our first element, we got this element done. Now we need to fill the rest of them. So how do we fill that? So we are checking the maximum. So how do we get the maximum? How do we get this number? So we already have the maximum up to the previous point. We simply need to check if this previous point is greater than the current value. If current value is greater, we'll push it here. Otherwise, the previous value is retained. So we can do something like this. Maximum dot pushback. Here we will check max of the previous max value. Maximum of I minus 1, comma, the current value, which is nums of I. So if we do this, we get the maximum values at every iteration, and we build this array. Okay, so let's assume that we already have this array, and then at every point we'll start to build the conversion array now. So what is the logic for conversion array? Conversion array is array of I plus max of array of 0 to I. So we already have this value. We simply need to do addition of this. Okay, so let's do that. Conversion dot pushback will be nums of I plus maximum of I. So when we say maximum of I, now I is 0 at the first point, So we get this value. When the I is 1, we get this value. So we add 3 to 3 and then we get 6. So when we are at the third place, we add 7 with 7, we get 14. When we are at the fourth place, we have 7 plus 5, 12. When we are at the fifth place, we have 10 plus 10, which is 20. Okay, so that's how our conversion array will be built. Okay. And now we need to fill the remaining piece. This is the answer array. So what is the logic for answer array? Return an answer array of length where answer of I is the score of the prefix nums of I. So we need to fill the score here. So how do we get the score? Score of an array ARR as the sum of the values of conversion array of ARR. So we just need to get the sum of the values. Okay. So when we are at 0, the sum of conversion array is just 4. When we are at 1, the sum answer array of 1 will become the sum of these two, which is 10. When we are at 2, the sum of these three values will become 24. 24 plus 12 becomes 36. 36 plus 20 becomes 56. And this will be our answer that we will return. So how do we fill this? So we know that the first element is straightforward, nothing to calculate. So if I equal to 0, answer dot push back, we simply get conver of I. So the first element from the conversion array will be pulled down to answer array. But if it is not 0, then we need to calculate. So how do we calculate? Answer dot pushback. So this is prefix sum. Now we are doing the technique of prefix sum. So we don't need to calculate the sum again. We are using the technique of prefix sum. So we just need to sum up these two numbers. So how do we get that? We already know the sum of the previous element, which is 4. We just need to add the current element to 4 plus 6 will become 10. So let's do that. So we get answer of I minus 1, the previous answer, plus conver of I. We are adding the current element. That's it. So we have our answer array. So we simply return answer. Okay. So that is our logic. So we made use of an extra space here to simplify the calculation of maximum. If we don't do this, we will have to use a nested for loop to calculate the maximum for each iteration of I, which we need to avoid. And again, at the end, when we need to calculate the sum of every element of the conversion array, we don't need to write another loop. We can simply use the concept of prefix sum to do this. Okay. So that's our logic. I think this also helps us with the dry run. So we can directly get into our code. Okay, let's go to Leet code and let's start building our array. So what do we need? We need 3 vectors now. Now here you will notice that the return type is not integer vector, it is long vector. So we will simply declare our vectors in the same way. So first vector that we need is conversion array, convert, and we also need our answer array, answer vector, and now we also need our maximum vector. Okay, these are the vectors we need, and our logic will be simple. We'll simply use a for loop. We will iterate over the array only once. I less than nums dot size and I plus plus. So the first step, getting the maximum up to our index. So how do we get the maximum? The first one is quite simple. If I equal to 0, there is no maximum to check. So maximum dot pushback will be nums of, so that will be the first element. But if there are no elements, if it's not zero, if it's not zero, we need to calculate maximum dot pushback. Here we check which is the maximum. Is the current element maximum or the previous one? So maximum of maximum I minus 1 comma nums of I. So whichever is the maximum will get pushed into the maximum vector. So we're building this one. Now let's build the conversion vector. So conversion vector is simple. Convert dot pushback. We simply need to add the current element and get the maximum one. Current element is nums of I, and get the maximum value, maximum of I. So we filled our second vector. Now let's fill our last vector, which is the answer vector, which will be the prefix sum. So for this, if I equal to 0, nothing to calculate. So answer dot pushback will become the first element of conversion vector. If it is not 0, then we calculate. How do we get this answer? Answer is the sum of the values of conversion array. So we simply get the answer of previous value in the answer vector, and we simply add the current element from the conversion vector, and that's it. So we simply return our answer. Okay, so let's see if we have done this right. We made some mistake. Maximum of I minus 1 nums of I. Max of maximum of I minus 1 comma nums of I. What is wrong here? I think the issue is with typecasting. Let's see if we can convert this to long and then check. This is a spelling mistake. This is convert. Let's run it again. Yeah, and that's it. So we can submit now. So that is solved. So as we can see, this max function is taking two arguments and both of them need to have the same data type. So we just did a typecast of integer value, which is in nums of I, to long, so that the max function works, and then the rest of the logic is same. Okay, so this is how we can use the prefix sum to solve this question. So the takeaway from this is we have used the maximum vector as additional space. So if we don't use this, we have to calculate the maximum value for every iteration of the array, which would be time consuming. So we have avoided that, and we have used the technique of prefix sum here to calculate the sum of elements in the conversion array, and we have done all this in one iteration of the main vector. Okay, So that's how we have solved this question. So the time complexity is n because we have iterated only once. And space complexity is n here, n here, and n here. So we have three n's. So three n's is usually considered as n in terms of space complexity. So that's where it is. So that's it for this video, guys. Thank you so much for watching. If you have any question, please do ask me. And please don't forget to leave a like. Please subscribe to the channel. I will see you in the next one. Thank you. Cheers.